Hello guys, so we are back again, and in this session we are going to continue with the fourth type. Okay, and we have done three types of problems in limits already and discussed how to solve them effectively, which were 0 by 0, infinity by infinity, 0 into infinity. And now we are going to see the type fourth, which is infinity minus infinity. Okay, infinity minus infinity. How we are going to solve this? Okay, and what are going to be the essential steps? Okay, what is going to be the path to solve this type of problem? We will discuss on that. But before starting with the lecture, okay, I want to say that please subscribe the channel, show your support, so we can bring more engineering content to you guys, so that you can secure a good marks in your academic years, okay, of mathematics. So let's begin with the questions. Okay, with infinity minus infinity form, not with the question. First we will understand the theory and what pattern we will follow in this type of question effectively. That we will discuss first, and then we will move on to questions. In this session we are going to just understand, okay, how this type of limit can be solved. Indeterminate form, okay, you can say indeterminate form. So first, if I suppose I have a function f of x, well, limit x tends to a, and if I substitute some value I get infinity. X equals to a, I get in function f of x, I get infinity. Suppose I have a function g of x, limit x tends to a, I substitute x equals to a, I get infinity again. If I do this, that limit x tends to a, if I subtract both the functions f of x and g of x, okay, since they are tending to a, now by property of limit I can apply limit to both of them, which is f of x minus limit f x equals to a g of x. That is substitution. I can substitute in each of them their respective values to get the answer. So if I substitute, here I will have infinity, here I will have infinity. So we are getting infinity by infinity, which infinity minus infinity, which is an indeterminate form. How we are going to solve this? We have to convert it into what? 0 by 0 or infinity by infinity form always. But how? Using transformation, okay, algebraic transformation, using algebraic transformation. Now what transformation do I meant, okay, when I mean algebraic transformation? I mean, okay, whenever they will give you something like that, okay, in this type of problem we will always do one single step, which is taking LCM, okay, LCM, which is very important. Then substituting and checking. What checking we are going to do? Checking whether by taking LCM, okay, by taking LCM, you should know LCM full form. LCM, the given infinity minus infinity form is converted to 0 by 0 or infinity by infinity form. And if it is converted to 0 by 0 or infinity by infinity form, which will happen for sure, then we will move to the same thing which you used to do in 0 by 0, 0 into infinity, infinity by infinity, okay, L'Hopital's rule. Then we will move to L'Hopital's rule, okay, which we have been doing in all the rest of the three types which I have just discussed earlier. So this was the complete path which we are going to follow to solve each of these questions which belong to these types. Okay, now let's begin with the questions. The first question which we are going to encounter, let me get the questions. Okay, okay, so we are going to start with the questions. The first question which we are going to see is this question. The question says as follow: limit x tends to 1. Okay, limit x tends to 1 upon log x minus x by x minus 1. First step in engineering examination. Okay, engineering, when you sit for the examination, you means if you are able to find the answer, to get the answer, okay, that will not make that you will get complete marks. Your representation matters here. First step, always write this: L equals to limit x tends to 1 bracket 1 by log x. Just write this because it is very important. You have to write this step. After this, you have to substitute x equals to 1 and let the teacher know that which form it is, or which type of limit or indeterminate form it is forming. When a moment I substitute, I get log 1. Log 1 is what? Log 1 is 0, and 1 by 0 is what? Infinity. Here if I substitute, it will be 1. This will be 1 minus 1, which will be 0, and 1 by 0 again is what? Infinity. So we are getting infinity by infinity, which is the indeterminate form, as I mentioned. Now what we are going to do, taking LCM. The moment I take LCM, this L, limit x tends to 1, what I will have? X minus 1 into x log x upon x minus 1 into log x bracket. Now we will substitute and check what value we are getting. The moment I substitute 1 here, this will become 0, this will become 0, and this will become 0. Okay, so I am having 0 by 0 indeterminate form, which is a good news for me because I know how to handle 0 by 0, infinity by infinity, and 0 into infinity indeterminate forms. What I will do, I will apply. Okay, I will check whether I can do some manipulations. Okay, means can I modify the denominator? Here there can be no modification of denominator can be done, so we'll directly move to apply L'Hopital's rule. L'Hopital's rule, we get what? We get limit. Okay, what was the L'Hopital's rule? L'Hopital's rule was differentiating numerator and differentiating denominator, which will give you 1 minus log x minus 1. Log x by x is 1 upon, here it will be 1 minus x minus 1 by x plus log x. Okay, so this was differentiation part. Now what I will do, I will just substitute and check whether which form I am getting. The moment I substitute, first I will modify this: limit x tends to 1. I am having minus log x upon x minus 1 by x plus log x, right? So if I substitute my 1, I will be left with what? I will be left with here, it 1 log 1 is what? 0. 1 minus 1 is 0, again log 1 is 0. So I am still having what? 0 by 0 indeterminate form. So I will continue doing what? Apply L'Hopital's rule again. Apply L'Hopital's rule again. You don't need to mention again, but you can just say apply L'Hopital's rule. I will apply the L'Hopital's rule again, which is nothing but differentiating f dash x upon g of g dash x. Okay, because here it has become f dash x upon g dash x. I will differentiate it, which will give me 1 by x upon, okay, what I will get here, I will apply quotient rule. Which will give me x square x minus x minus 1, and here it will be 1 by x. If I modify this, I will be left with 1 by x, limit x tends to 1. Here x will cancel out, minus 1 by x square plus 1 by x. What we are getting is nothing but, if I substitute 1, I will be left with minus 1. If I substitute here, wait, what we are having, minus 1 by x. okay, and here we are having this is 1 by x, okay, so this will become 1 upon x square, and here this is what, this will become plus 1, sorry, this will become plus 1. So if I substitute, I will be left with 1 plus 1, which will be nothing but minus 1 by 2. So here we are getting a finite value, which means we are going to stop applying L'Hopital's rule and end our question here. But remember, you don't need to forget this last step, which if you don't do that step, your marks will be deducted. You will not get the complete marks, which is writing limit x equals to, limit x tends to 1 upon log x minus x by x minus 1 equals to this finite value, okay, which will give you complete marks. Now let's move on to the next question. So the next question is as follow, which is this question, which says limit x tends to 0 1 upon sine square x minus 1 upon x square. So we are going to solve this problem. So first step is, as I mentioned you, limit x tends to 0, you have to write the same thing, and in the next step you have to let the teacher know what form it is by substituting the value. Since sine 0 is 0, so 1 by 0 is infinity. Similarly, 1 by x square, when you substitute 0, you will get 1 by 0, which will turn out to be infinity. So you are getting infinity minus infinity in determinant form. What is the next form? Taking LCM, we get, you have to mention this statement. The moment you take LCM, you will get limit x tends to 0, x square minus sine square x upon x square sine square x. This is the thing which you will get. Now if we can do one simple manipulation, okay, which will be but before doing that, let's check what form it is. Okay, substitute the values, you will get 0 minus 0 upon 0, which will be 0 by 0, which is again an indeterminate form, but it is a good sign because we have converted infinity minus infinity to 0 by 0 form. Now in the next step we are going to, now can I modify my denominator? Yes, for sure. Whenever sine square, tan square, okay, these type of terms appear, try to multiply them, okay, but never, after the step, never split that term, okay, unless and until, okay, the function, okay, like unless and until you have single x, okay, like we used to read in the previous problem. So multiply and divide by x square, we get, multiply and divide by x square, divide in the denominator, okay. This is not, okay, this is not your IIT JEE examination that you will directly write the answer, okay. You have to mention each and every step, otherwise your marks will be deducted even though your answer is 100% correct. So the moment I apply, I will have x square sine square x, here it will get x power 4, I will be left with sine square x by x square, which in the next step, this thing sine square x will become, okay, I will write one more step which will make you more clear what is happening. X square minus sine square x upon x power 4, this will be sine x by x the whole square bracket. So finally you will be getting answer, limit x tends to 0, answer will be x square minus sine square x. Now don't, okay, by mistake separate or distribute the x power 4, you will get infinity minus infinity form again, which will be a troublesome for you, okay. Okay, so after this step, what we are going to do, we are going to substitute and check what its nature is. Its nature is 0 by 0, which is again indeterminate form. What we are going to do, we are going to apply L'Hopital's rule. Apply L'Hopital's rule. L'Hopital rule, which is differentiate the numerator and the denominator. You will get 2x minus 2 sin x cos x by 4x cube, okay. After this step, check what you're getting. We will divide throughout by, okay, this 2 will cancel out this, we will be left with limit x tends to 0, x minus sine, okay, should I write it cos 2x or should I keep it as it is? Okay, let's keep it as it is. so that we can write it sine 2x. Okay, I will write it sine 2x upon 4x cube. After this step, what we are going to do, we are going to check its nature. It is still, if you substitute the value, you will get 0 minus 0 by 0, which is again an indeterminate form. After this, what we are going to do, if I am getting 0 by 0 indeterminate, we are going to apply L'Hopital's rule again. Apply L'Hopital's rule. The moment you apply L'Hopital's rule again, what you will get, okay, what you will get is as follow: 2 minus cos 2x into 2, here it will become 12x square. If you substitute the values, okay, if you take the 2 outside, you will get cos 2x. I forgot to mention the limit, okay, 6x square. Apply L'Hopital's rule again. Why? Because if you substitute, you will get 1 minus 1, okay, and here you will get again 0 by 0 format. So our intention is to get what? You are again getting 0 by 0 form, which is indeterminate form. Our aim, okay, is to get a finite number. I will apply L'Hopital's rule again, which will give me this time 2 plus sine 2x. Oh wait, this 2 will be not there. There will be. I will apply L'Hopital's rule. This will become 0. Cos x will become sin x. Okay, plus sine 2x into 2 upon this will become. This was 12, which was cancelled out and became 6, and this will become 12x. After this, we can write this 12 will, okay, this 6 will this 12 will cancel out, and again I will be left with sine 2x upon 6x. Now you can substitute, and you are again getting 0 by 0 form, which is indeterminate form. Apply again L'Hopital's rule. Apply again L'Hopital's rule. What you can see, what you are getting, we are getting cos 2x into 2 by 6, which is nothing but this 2 will cancel out this 6, which will be left with cos 2x, okay, by 3, which will give me finally 1 by, okay, if I substitute, I will be left with 1 by 3. So this is our answer. You have to write the statement again and mention that it is equal to 3, 1 by 3, and you will get the complete marks. Now let's move on to the next question. Now one more thing, this question which I have just did, you can solve it by expansion. Since I have not taught the expansion, I will not do, okay, I will try to use the general method, but if there is no other way around, we will use the expansion. Now let's begin the next question, which is probably the last question of this session. So the last question of this session, let's remove this page, is this, which is limit x tends to 0, 1 upon x square minus 1 upon tan square x. And this question, we will write the first step, limit x tends to 0, tan square x. Okay, we are going to first substitute the values by writing the same thing. Then after this step, if you substitute, you will get infinity minus infinity, which is an indeterminate form. And the next step, you will take taking LCM on both sides, which will give you limit x tends to 0, tan square x minus x square upon x square tan square x. If you substitute the values, you can see tan 0 is 0, 0 minus 0, 0 by 0, indeterminate form. Since it is an indeterminate form, what I can do, here my denominator is tan square, okay, if there is sine square, tan square, okay, anything like that, we will try to do the modification, okay. So divide and multiply by x square in denominator. What we will get? Tan square x minus x square upon this will become 4, and this will become tan x by x the whole square. Now you can directly write the reason or substitute the value, or you can do this thing. like here I am doing. Separate the limits. Okay, here the whole square. After this step you will write only this thing will be left, which will be tan square x minus x square upon x power 4. Now here, okay, the differentiation will become difficult, so we are going to move on with the expansion thing. Okay, when we will study expansion stuff, okay, we will discuss. Okay, for the timing now I will just tell you the expansion of tan square x. Okay, and you have to just keep in mind, okay, that expansion, and just substitute the value like what I am doing. The tan x expansion is as follow: x plus 1 by 3 x cube plus 2 by 15 x power 5 and so on. You need to just remember till 5 terms. Okay, and tan x expansion, okay, there is no shortcut in that. Okay, no trick to remember it. Okay, I will tell this thing also in expansion of function, but just keep in mind. Now tan square x, okay, I need my this question as tan square x. Okay, so I will find tan square x expansion. Okay, how I will find tan square x expansion? It will be like this. Tan square x expansion will be this: x plus 1 by 3 x cube plus 12 by 5, sorry, 2 by 15 x raised to 5 plus and so on, the whole square. Now I will try to consider the terms. Okay, I will try to consider the terms which are like this. Okay, if I consider this, I will do one simple thing. When I substitute this value in the expression, x plus 1 by 3 limit x tends to 0, 1 by 3 x cube plus 2 by 5 15 x raised to 5 the whole square minus x square upon x raised to 4. I will expand till x raised to 5 only. Okay, till x raised to 4. Okay, I will not consider this x raised to 5, and I will try to consider the terms which are less than, okay, or equal to 4 in this expansion. So my limit will be till x raised to 3. My 4 is not, x is 5, which is greater than 4, so I will not consider it. You will study this thing in expansion of function in very detail, so don't need to worry. Okay, now x square by x raised to 4. Now I will use a plus b the whole square and try to create the term possible. Here there will be one more term a square, another term will be 2ab, which will be still x raised to 4, so I will consider that in the last term will be x cube by 3 the whole square, which will be x by 6 by 9. Since it is x raised to 6, so we will not consider that. We need power equal to 4 or less than 4, so I will consider only those terms in the expansion which are, okay, equal to or less than equal. So it will be 2 by 3 x raised to 4, okay, and plus, yeah, there are many terms, I will just represent it by dot 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 and so on, minus x square upon x raised to 4. If I solve this, okay, substitute the values or open them, you will know that this and this will cancel out, and this x raised to 4 will cancel out with this, so I will be left with 2 by 3, which is our answer. Hope you have understand this problem. Now you have to just write that x square minus 1 by tan square x is equals to this, and you will get the complete marks. Now we are done with this session. If you like our content and want us to bring some more content like this stuff, okay, so that you can score better marks in your engineering semesters, so please like the channel and subscribe it and share it with your friend. See you in the next video. Till then, take care. Bye.